Imagine you're standing in a pitch black room and you flick a light switch. To your eyes, that light fills the space instantly. But here is the mind blowing truth: it's actually moving at roughly 300,000 kilometers per second. It is the absolute speed limit of the universe. And if you could travel that fast, you could circle the entire Earth 7 times in a single second.
Okay, 7 times in a second is fast, but instant still feels more accurate for my daily life. Why does that tiny delay even matter? And how on earth did we figure out the exact number if it's that fast?
It matters because that speed is the bedrock of physics. It's the C in Einstein's EOMC2. Today, we're diving into the history of how we clocked the fastest thing in existence and why the universe won't let you go any faster. For most of human history, people actually thought light was instantaneous. Even brilliant minds like Aristotle believed light wasn't a moving thing, but a sudden presence. It wasn't until the 17th century that scientists started to get skeptical.
So what changed? Did someone just try to time a candle flame across a field?
Galileo actually tried that. He and an assistant stood on distant hills with covered lanterns. One would uncover his light, and the other would uncover theirs as soon as they saw the flash. But light is so fast that the human reaction time made it impossible to measure. They concluded it was either instantaneous or just extraordinarily rapid.
That sounds like a failed experiment. Who finally broke the code?
A Danish astronomer named Ole Romer in 1676. He wasn't even looking for the speed of light. He was studying Io, one of Jupiter's moons. He noticed that the timing of Io's eclipses changed depending on where Earth was in its orbit around the Sun. When Earth was further away from Jupiter, the eclipses happened later than predicted.
Wait, so the delay was just the light taking longer to travel that extra distance across space? That's genius. He used the solar system as a giant stopwatch.
Exactly. He calculated that light takes about 22 minutes to cross the diameter of Earth's orbit. While his specific number was a bit off because he didn't have perfect distances for the planets, he proved once and for all that light has a finite speed. Once Romer proved it wasn't instant, the race was on to find the exact number. In the mid-1800s, Hippolyte Fizeau took it back to Earth. He shone a beam of light through the teeth of a rapidly spinning wheel toward a mirror 5 miles away. By timing how fast the wheel had to spin for the light to pass through one tooth and return through the next, he got a very close estimate.
That sounds incredibly mechanical for something as ethereal as light. Did we get a final answer before the digital age?
The real breakthrough came from James Clerk Maxwell. In the 1860s, he developed equations for electromagnetism and realized that electromagnetic waves travel at exactly the speed light does. This revealed that light isn't just bright stuff, it's a wave of electric and magnetic fields dancing through space.
So we figured out what it is and how fast it goes. But then Einstein enters the chat and changes the rules, right?
He changes everything. Before Einstein, people thought light moved through a medium called ether, like sound moves through air. But experiments like the Michelson-Morley test showed the ether didn't exist. Einstein realized that the speed of light, which we call c, is the same for everyone, no matter how fast they are moving.
Hold on. If I'm on a train going 100 miles an hour and I shine a flashlight, isn't the light going speed of light plus 100?
You'd think so, but no. The light still moves at exactly c to you, and exactly c to someone standing on the side of the tracks. To make that work, time itself has to slow down for you on that train. This is time dilation. The speed of light is the only constant. Space and time are the things that bend to accommodate it.
That hurts my brain. So the speed of light isn't just a number, it's the governing force of how time passes.
Precisely. And in 1983, we stopped measuring it entirely. Scientists decided the speed of light was so fundamental that they redefined the meter based on it. Now, a meter is officially defined as the distance light travels in a vacuum in 1,299,792,458th of a second.
If we got the number locked down, why is this still such a huge deal in modern science? Is it just about high-speed internet cables?
It's the ultimate barrier for our future in the stars. Because nothing with mass can reach the speed of light, it would require infinite energy. We are effectively locked into a cosmic slow lane. When we look at a star that is 100 light years away, we are literally looking 100 years into the past.
So the speed of light is basically a lag time for the universe. We can never see the now of the sun, only the 8 minutes ago of the sun.
True. It also dictates our technology. GPS satellites have to account for these tiny light speed delays and relativistic effects, or your phone would think you're in the wrong city within a day. Even high-frequency traders on Wall Street fight over microseconds because that's the time it takes light to carry data through fiber optic cables between cities.
It's wild that a measurement from the 1600s is why my Google Maps works and why we can't visit Alpha Centauri by next week.
It defines the boundaries of our reality. It's the maximum speed of information. If the sun disappeared this second, we wouldn't even know it. And Earth wouldn't fly out of orbit for 8 full minutes because gravity also travels at the speed of light.
So it's not just the speed limit, it's the speed of causality itself.
Exactly. Nothing happens until the light speed memo reaches you.
All right, what's the one thing to remember about the speed of light?
The speed of light is the universe's only absolute constant, acting as both a cosmic time machine and a hard limit on how fast cause can lead to effect.
That's Wikipedia, every story on demand. Search your next topic at wikipedia.ai.